ambulance is written backwards? This reverse writing of the word ambulance is not a mistake. When viewed through the rearview mirror of a car, a mirror image correctly shows the word ambulance, and the driver can quickly identify whether or not he or she should get out of the way. In geometry, we refer to a reflection as a mirror image. Unlike dilations, a reflection is not a change in size. A reflection is also not a change in shape. For this lesson, we will need to be familiar with common lines of reflection. We know the x-axis as the horizontal line that passes through the origin, the y-axis as the vertical line that passes through the origin, the vertical line equation x equals k, in this case k equals 3, the horizontal line equation y equals k, in this case y equals -2, the line y equals x, and the line y equals -x. When reflecting a point, line, or figure about a given line of symmetry, we use the lowercase r notation. This notation will specify the line of symmetry for which our reflection will occur. Cool. For our first example, we will be reflecting a point. Notice that our line of symmetry is the x-axis. This is the line that we are going to be reflecting our point P with coordinates 5, 4 across. To find the coordinates of the image P prime, we will count how many units the point P is away from the line of symmetry, in this case 4 units. Next, we will count the same number of units on the other side of the line of symmetry. So again, 4 units. Now we have the location of the point P prime with coordinates 5, -4. When reflecting over the x-axis, we should notice that the value of the x-coordinate did not change. However, the value of the y-coordinate was negated, going from 4 to -4. This reflection rule applies to reflecting any point over the x-axis, where the coordinates xy will become x -y, meaning that the value of the y-coordinate is negated. Now we can take a look at taking that same point P and this time reflecting it over the y-axis. Our approach here is still the same. We're going to count how far away the point is from the line of symmetry, in this case 5 units. Then we can count the same amount of units on the other side of the line of reflection and plot the point P prime. The coordinates of this image at -5, +4. Notice that when reflecting over the y-axis, the x-coordinate value is negated and the y-coordinate value is unchanged. In terms of a reflection rule, you can say that any point reflected over the y-axis with coordinates xy becomes -xy, where the x value is negated. For our next example, we are going to reflect a line segment. Our line of symmetry x equals -2 is a vertical line equation. Let's start by writing down the coordinates of the endpoints QT. To find the coordinates of the image Q prime T prime, we'll use the same strategy as the last example by counting how many units each endpoint is from the line of symmetry. We see that the point Q is 2 units away from the line of symmetry x equals -2, and the point T is 6 units away. We can go ahead and repeat those distances on the other side of the line of symmetry and plot the new points of Q prime and T prime. Now we can construct the image of the reflected line segment. Q prime has coordinates of -4, 7, and T prime has coordinates of negative 8, 3. Now we can go ahead and try to reflect line segment QT over the line of symmetry y equals 3, a horizontal line equation. Notice here that the point T is directly on the line of symmetry. Just like pressing your finger up to the surface of a mirror and having it appear that another hand is directly touching it, having a point directly on the line of symmetry will have it stay on the line of symmetry. So T prime will have the same coordinates as T at 4, 3. Now the other endpoint Q still needs to be reflected. Again, we're just going to count how many units Q is from the line of symmetry. We count 4 units, and we repeat that distance on the other side, again another 4 units, and plot the image of Q prime. Finally, we can construct line segment Q prime, T prime, and identify the coordinates of Q prime at 0, negative 1. And finally, for our last example, we are going to take a shot at reflecting a figure. In this case, we will be reflecting triangle BCD across the line y equals x. We can start by writing down the coordinates of the vertices of triangle BCD. We can start by counting on a horizontal path how many units each point is away from the line of symmetry. We see that B is 6 units away, D is 7 units away, and C is 12 units away. Now, since y equals x is a vertical line equation, when we count on the other side of the line of symmetry, we're going to move vertically. So we started horizontally on one side, and now we're going to count vertically on the other side. By matching the same number of units for each corresponding point, we can find the coordinates of B prime, C prime, and D prime. Finally, we can construct the reflected figure. The coordinates of B prime at 1, 7, the coordinates of C prime at negative 6, positive 6, and the coordinates of D prime at negative 5, 2. Now we can compare the pre-image and the image after the reflection by turning the graph and seeing just how these two figures are reflected over the line y equals x. Notice the coordinates of B at 7, 1, and B prime at 1, 7, C at 6, negative 6, and C prime at negative 6, 6, and D at 2, negative 5, and D prime at negative 5, 2. This relationship applies to any reflection over the line y equals x. When you have a point P with coordinates x, y, the x and y coordinate values are switched. The y coordinate value comes first and the x coordinate value comes second. The signs do not change. And now we can take a look at reflecting this figure over the line y equals negative x. Again, let's start by constructing the line of symmetry and writing down the coordinates of the vertices of triangle BCD. Notice here that the figure is resting on top of the line of symmetry and is in 2 different regions. Now we know that since point C is directly on the line of symmetry, C prime will have the same coordinates of 6, negative 6. Next, point B is located above the line of symmetry. We'll start by counting the number of units horizontally it is away from the line of symmetry, 8 units. The next step is to repeat that same number of units vertically on the other side of the line of symmetry to find the coordinates of B prime. And finally, since point D is below the line of symmetry, we'll start by counting how many units vertically it is away from the line y equals negative x, and then repeat that distance moving horizontally above the line of symmetry. Now we have the coordinates of D prime at 5, negative 2. By connecting those vertices, we construct the image of B prime, C prime, D prime to create a very interesting picture. We can rotate the graph to better visualize what this reflection looks like. Now we can compare the point B with coordinates 7, 1, and B prime at -1, -7. C remains unchanged, and D with coordinates 2, -5 to D prime 5, -2. If you notice for this relationship, when reflecting any point over the line y equals -x, the x and y values are switched and negated. So xy becomes -y, -x. And now our final words on reflections. A reflection is a mirror image across a specified line of symmetry. For these transformations, you may apply reflection rules for common lines of symmetry. These common lines of symmetry include the x and y axis, the lines x equals k and y equals k, and the line y equals x and y equals -x. Thanks a lot, guys.